Hey students, today we're going to do section 4.5, which is systems of equations and problem solving. So most of the problems in this section are going to rely on what you've already learned about solving systems of equations, but they're going to add an extra layer of complexity in that they're going to be word problems where you have to create your own system of equations. The trick with these or the technique to solving these problems is that you really want to read the problem and reread the problem and make sure that you understand what is being asked. Okay, so that's the first step. The second step is assigning your variables. Okay, there's going to be more than one quantity here that we're going to look for, and each different quantity is going to get its own variable. So unlike before where we tried to just use one variable, now we are going to use multiple variables. So you want to make sure that you pick the variable you want to represent each quantity and understand what quantity that variable represents. So I like to use X's and Y's, but sometimes you may want to use letters to represent variables. Pick a letter that is basically like the first letter of that variable's name. So if you, for example, are trying to figure out how many pies somebody has and how many cookies somebody else has, you can use P for pies and C for the number of cookies, right? So you want to assign your variables first. And once you've got those variables assigned, then you have your letters that you can start using in your equations. Then you go back and read that problem one more time, and you create your equations. Remember, you should have the same amount of equations as you have variables. In most of your problems, it's going to be 2 variables and 2 equations. Maybe you'll get one advanced problem that gives you 3 variables and 3 equations. So the best way to work on these guys is to just dive in to doing some examples, right? So I've got our first example here. If I add the money in both of my pockets, I'll have $28. One of my pockets contains 3 times as much money as the other pocket. How much money is in each pocket? So here we want to assign our variables. I'm going to call the money in one of my pockets X and the money in one of my pockets Y. Okay. And then I know that if I add X plus Y, I'm going to get $28. So that's my first equation. I also know that one pocket has 3 times as much as the other pocket. So if I multiply the amount of money in one pocket, it will equal the amount of money in the other pocket. Here is where we differentiate our variables X and Y. Clearly, X is the pocket. X is the amount of money in the pocket that has 3 times as much, right? So Y is going to be the smaller quantity. X is 3 times Y. So we assigned our variables. X is the amount of money in one pocket. Y is the amount of money in another pocket. We have 2 variables, so we need 2 equations. We set up our 2 equations. They add to get to 28. It tells us that in the first sentence. And the value of one of our pockets is 3 times the value of the other pocket. Once we've got these 2 equations for these 2 variables, we can go right into solving this. A lot of times when you just have 2 equations and 2 variables, it's easier to use substitution. So since our second equation is already solved for X, we can just replace the X in our first equation with a 3Y. Because we know that X is equal to 3Y, we can say that 3Y plus X equals 28. So that tells, 3Y plus Y equals 28. So 4Y equals 28. So Y equals 7. And then once we know that Y equals 7, we can multiply it by 3 to get X is 21. Very last thing you want to check. If I have $21 in one pocket and $7 in another pocket, does that add up to 28? Yes. If I have $7 in one pocket, is 3 times 7, 21? So I have 3 times as much in the other pocket? Yes. Okay. So that's how these problems work. You have to create your own equations. If you're getting stuck creating your own equations, make sure you have first assigned a variable to each quantity so that you have a piece to grab onto to use into your equation. Let's do one more example. Carlos and Randy have a jar that contains 85 coins. All of these coins are either quarters or nickels. The total value of the coins in the jar is $12.05. How many of each type of coin do they have? This question is a little bit tricky because we want to know about the number of coins. Okay, how many pieces of coins? But one thing that they give us is the total like dollar value of these coins. Okay, so you want to really understand what are our variables going to represent. We want a variable to represent the number of nickels. Let's call it N. And we want a variable to represent the number of quarters. Let's call that Q. But remember, a nickel is worth 5 cents and a quarter is worth 25 cents. So we know that N plus Q is going to give us 85, right? The number of quarters plus the number of nickels will give us 85 coins. But when setting up the second equation, when we said the total value of coins in the jar is $12.05, we have to remember, how would you calculate how much money you have if you have a certain number of quarters and nickels? Well, the quarters are each worth 25 cents. So Q times 0.25 is how much money you have in quarters. And N times 0.05 is how much money you have in nickels. So you add those together and you'll get the total of $12.05. That's how we come up with these two equations. The number of quarters plus the number of nickels gives us 85, right? A count of 85 coins. But if we multiply the number of quarters times their value, and we add that to the number of nickels times their value, we're going to get the total value of money that we have in this jar, $12.05. So that's how you're going to set up your two equations there. Tricky part here is realizing that Q and N represent the number of coins because we've decided they should, not the money value of those coins, okay? This one's a little bit trickier to solve. You can use substitution like we did before, or you can use elimination. But remember, you have decimal coefficients, which is a little trickier. And in the end, you should end up with 39 quarters and 46 nickels. If you want to try this one, try solving this one on your own to make sure that you understand how to solve systems of equations. That's great. The tricky part with these, though, really is coming up with this system of equations. All right. If you need to work through those examples again, maybe try setting up the equations on your own, just using the example. And if you set up different equations, sometimes that's okay. See what you get when you solve them. And if you still get the correct answer, then you've set up your equations correctly. There's sometimes more than one way to set up these equations. Okay, that's all we're going to do for 4.5. It just takes a lot of practice and time working through these problems, but you'll be able to get it if you just give it a little bit of practice. All right, you guys, have a good day.